This is for the Lapham concentrations, the method of successive dilutions, and it says load homework, acid and bases, and then method of successive dilutions. There it is. Okay. Then my instructions say on your workbench assemble the following stock solution of glassware: a 1 molar hydrogen chloride or hydrochloric acid Erlenmeyer flask. So that's this one, of course. Then 5 100 milliliters volumetric flasks. Right click on each and label them solutions 1 through 5. So I'm going to grab them here, volumetric flask, there it is. And actually what I do now is right click on it, and there it says rename, and now I'm going to call it solution 1. Okay, and now I'm going to copy it, and now I'm going to paste, Control V. I'm going to do that 3 more times, Control V, and then again rename solution 2 and 3 and 4 and 5. Okay, and then it says a 10 milliliter pipette. So, there it is, and the distilled water container. There we go. Okay, preparing solution 1. With the pipette, draw 10 milliliters of hydrochloric acid. So I'm going to put that on top of it, and then I'm going to type in 10, and then it says withdraw, and fill with the from the pipette into this, with the pipette, draw 10 milliliters of hydrochloric acid. Dispense the acid from the pipette into solution 1 volumetric flask. So in there, so I'm going to say 10. Pour. There we go. And fill with the necessary amount of water to make a 100 milliliter solution. So I'm going to pour, of course, 90 milliliters in to make 100 milliliters of solution. Okay, then how much water did you need to add? That's the 90 milliliters. Remove the 1 molar acid Erlenmeyer flask from your workbench so you don't accidentally use it anymore. So I'm going to take this one off here. I think there it says, okay, that would be out of the picture. Whoops. Okay, there it says remove. There we go. Okay, now let's see how it goes on. It says preparing solution 2. Pipette 10 milliliters of solution 1 into solution 2. So I'm going to withdraw 10 milliliters from this one, and I get in this one. 4. Okay. And then dilute to 100 to the 100 milliliter mark. So I pour 90 milliliters in. There we go. Okay. And preparing solutions 3, 4, and 5 consecutively. Pipette 10 milliliters from the previously prepared solution into the next volumetric flask and fill with enough water to make 100 milliliters solution each time. So again, I'm going to take 10 out of here and pour it in there, and so on. And then, of course, top it off with water. Okay, this is where I stop so that I can leave some work for you. Okay, I didn't mean to do that. I just meant to move them to the side here so that I can look at the document. There we go. So here it says, what is the molarity of the hydrogen ions in solution 1? What is the pH value? Well, I click on this one here, and I'm going to read off here that the molarity is 0.1 and the pH is 0.99. So that's where I'm going to write 0.1 m, and here I'm going to write 0.99. That was actually supposed to be in black. And then here, compute the molarity of solution 1 using the dilution equation. So show your work. So it would be a concentration to begin with of the acid was 1 m times the volume that I poured in was 10 milliliters, and that equals then the concentration that I'm supposed to figure out right now times the volume that I have. And what I originally had was 100 milliliters. Notice that in the meantime I did take 10 milliliters out, but of course the 10 milliliters was from the total of 100 milliliters, which means I had also taken 1 milliliter out of this one. In any case, that was the original solution 1, and then I have 1m times 10 divided by 100, and that's going to give me 0.1 molar solution. And then you continue on with the others. You read it off here and you plug in the numbers here and calculate there.